Welcome you all for engineering chemistry classes. I, Dr. R.K. Patil from KLE College of Engineering and Technology, Chikkodi. Today we are going to discuss on solar energy, belongs to third module. So let us discuss about the introduction part of the solar energy. So when light striking certain substances causes the surface of the material to emit electrons. So it is as if the electrons are kicks right out of atoms. And in some other subjects, when light is striking, the material are going to accept the electron. So it is the combination of these two substances that can be made use to cause a flow of electron through conductor. So this is what we call it as a photoelectric effect. So here the solar energy is energy obtained by capturing heat and light from the sun. So energy from the sun is referred to as a solar energy, and there are many technologies which are there to convert the light radiations into solar energy. And also it is called as a green technology because it does not emit greenhouse gases. There are two type of utilization of solar energy. One is like a direct solar power. So direct solar power is nothing but formation of energy, or I can say it involves only one step transformation into a useful form. That means to get a kind of energy where there is only one step is involved is called as direct solar power. Another is indirect solar power, where it involves more than one transformation to reach a useful form. That means more than one step is involved to get useful form of an energy is called as indirect solar power. Let us go to discuss, or let me tell you about the photovoltaic cell. So photovoltaic cell is a device, we normally call it as a semiconductor device or a diode, which effectively convert the light radiations into electrical energy is called as what? Photovoltaic cell. So in this only, so there is not much difference in this photovoltaic cell and solar energy. So solar energy is a subset of photovoltaic cell, so which I can define in this way. A combination of P and N types of semiconductors is called a semiconductor diodes. These diodes, when exposed to a magnetic radiation, that is sunlight, the electricity is generated. So such devices are called as a photovoltaic cell or a solar cells. Now we'll go for the working of photovoltaic cell. Here I shown a diagram. I can't zoom it, but I'll tell you the green layer, whichever I am telling you people, that involves a metallic grid. So metallic, in that metallic grid, a very thin layer, or I can say a wafer of a silicon, right? And those are being coated with the anti-reflective layer. So we are using here a titanium dioxide as an anti-reflective layer which enhances the intensity of a light radiation. So that deposition of anti-reflective layer is done by plasma enhanced chemical vapor deposition technique, and below that we have an n-type silicon. So n-type silicon is formed by slightly doping with a phosphorus material, and below to that I have a p-type silicon that is slightly doped with a boron material. So the in between these two there is a p-n junction. We normally just want to show like a depletion layer, and here below to that I am again showing in a red color layer, that is a metallic contact or a metallic layer which is going to act as a contact, so which allows the electron to flow through it, right? And here let me briefly tell you, when light radiations are falling on a semiconductor diode, that is a p-n junction, so there is a formation of an electron and a hole pair, and the moment of this electron and a hole pair are moved to in a specific direction. That means the electrons are collected and drifted at the end of the n-type semiconductor, and similarly the holes are collected and drifted at the end of the p-type semiconductor. When these two is happening and there is a flow of electron from the metallic contact to the external circuit, and we have some light or something, then there will be a glow of the light because it shows or it indicates the flow of electron, and this process is going to be continuous. So that only I've just defined or written on the sides. You can read it carefully. So a metallic grid forms one of the electrical contacts, that is a green layer above the green layer. In that I shown an anti-reflective coating material, and the cells are other electrical contact formed by metallic layer on the back of the solar, that is whatever at the below green layer what I shown. When light radiations fall on the PN junction diode, electron hole pairs are generated by the absorption of the radiation. So after that the electrons are drifted and collected at the n type. Similarly, holes are drifted and collected at the p type end. And when these two ends are electrically connected through a conductor, there is a flow of current between the two ends through the external circuit. So this is all about the working of photovoltaic cell. The construction itself, as I already told, the construction is very simple. It includes a metallic grid. That metallic grid consists of the vapor, that is a silicon wafer, and that is again including an ultra thin layer of respectively the p type and n type silicons, and below that I have the metallic layer which is going to act as an electrical contact, and the anti-reflective layer, and that anti-reflective layer is been coated with titanium dioxide to improve the intensity. And this much you can write with respect to construction in the examinations. Right, moving on to the importance of photoelectric cell. So photovoltaic cell provides enormous amount of heat or energy from sun, which is unlimited, inexhaustible, like it's a reservoir, and even that is the solar energy is a renewable energy source. Photovoltaic cells can serve for both off-grid and on-grid application, and photovoltaic cells produce non-pollution, so it is environmental friendly. It provides power for spacecraft and satellite, like so on, the importance of photovoltaic cells. And coming to the next concept, that is the cells, module, array and panel. So this is a different type of PV cells. When I talk about cell, I am showing the cell here. It's a one cell which is capable to generate a small quantity of electrical energy, and the same thing, and more number of cells are been constructed or taken and connected either series or parallel to form a module which is capable to generate around about approximately 12 volts. Similarly, when I go for arrays, then in this array more number of modules are there with respect to the arrays. Then from arrays to the panel which includes more than one arrays which are connected only series. So that is, the panels are normally you might have seen on a house roofs, so which is capable to generate a large quantity of energy from the light radiations. Then the advantages of PV cell, there are many advantages as well as there are some disadvantages. The disadvantages, like sunlight is diffuse, that is it is a relatively low density energy. So all light radiations are not useful to convert the light radiation. That means there is some intensity required. So low intensity light radiations are not enough or not capable to convert light radiation, not capable to generate an electricity. The meaning is such. Okay. Then the high installation cost. So initially when we are installing the PV cells, not exactly PV cells, panels, it is of like a high cost, and poor reliability of auxiliary elements including storages, and and the energy can be produced only during the daytime. This is a very big disadvantages of this. We can produce the energy in during the only daytime. So next we go for the next concept, that is the manufacture of or the synthesis of union carbide process. We normally call it as, this is the name of the process in which we are going to synthesize solar grade silicon. So why particularly we are opting this? Like we have different type of an solar material, that is silicon material, like a metallurgical grade silicon, like a semiconductor grade silicon, and out of these two we have a solar grade silicon. So metallurgical grade silicon are very impure because it includes a large quantity of killer impurities. So killer impurities like are going to decrease the life of the charge carrier, so we cannot use to form or to manufacture the solar panels or PV cells. So if we select semiconductor grade silicon, then the cost of the PV cell is going to be very high, which is not affordable to a common man or poor people. So ultimately we have to think of a quality or a kind of a solar silicon which is effective, as well as the cost is also going to be reduced. So that's we are going to discuss, that is a solar grade silicon. That the properties of a solar grade silicon lies between metallurgical grade silicon and this semiconductor grade silicon. So here we are going to discuss with our syllabus. With respect to our syllabus, we have like a synthesis of solar grade silicon by union carbide process. So here the first step involves that tetrachlorosilane is subjected for hydrogenation on metallurgical silicon bed, right? I mean to say the tetrachlorosilane is subjected for hydrogenation in presence of or on the bed of metallurgical silicon. So where from which we are going to form the trichlorosilane, and the trichlorosilane is separated by distillation, and unreacted tetrachlorosilane is recycled back to the hydrogenation reactor. That means it is supposed to be recycled, sent back for the initial step to undergo. Then the purification of trichlorosilane is done by fractional distillation, and then it is going to be passed through on a fixed bed column that is filled with the quaternary ammonium ion exchange resin, which is going to act as a catalyst, and where the trichlorosilane is converted into dichlorosilane. The reaction is as follows. See here, trichlorosilane, when it is passed through on a column like a quaternary ammonium ion exchange resin, where I am going to form this dichlorosilane, and along with the dichlorosilane the some part of tetrachlorosilane is also formed, and this tetrachlorosilane is again sent back for recyclization, that is this hydrogenation reactor. Next to this, the products whichever is going to form, the same thing I have explained here, and again whatever the dichlorosilane is formed, again it is passed through on a second fixed bed column which is filled with the quaternary ammonium ion exchange resin, and here dichlorosilane is converted to silane. So this is an elemental material which we required for the formation of the polysilicon. Next to this, the same procedure is going to be followed, the purification, and whatever trichlorosilane is been again sent back for the hydrogenation chamber for further distillation, and after purification by distillation, this silane, what we can do, it is supposed to be subjected for pyrolyzation and to produce a polysilicon onto a heated silicon seed rods in a metal bell jar reactor. So where there is a formation of a silicon seeds on a silicon seed rods, which is supposed to be done in metal bell jar reactor. So where I am going to form the polysilicon here. So this is a synthesis part of silicon, that is a polysilicon by union carbide process. So students, this is very important question which definitely going to be asked in examination, so practice this. So this is end with respect to the solar energy.